So, welcome. I hope you all enjoyed the nice weather over the weekend. Today we're going to be discussing model view controller architecture. This is a bit more of an, you could say a bit more of an academic topic as opposed to our previous topics, most of which have been sort of quite practical. Most of the previous weeks we've been introducing a brand new programming language, but for a little bit of time we're going to take the time to set up the framework that we will be covering at the very end of the course, which is called Laravel. But in order to understand how something like Laravel works, we first have to discuss some of the architectural details of modern server architecture. Model view controller is an extremely popular design pattern. So, web programming is quite complicated. It has a lot of moving parts. Hopefully, over the course of this course, you have come to some kind of appreciation for exactly how much work goes into a modern web application. On the client side, we have, as our bases, CSS, JavaScript, and HTML. We need to know what the document object model is. A little bit of XML. We didn't actually really cover XML, but XML is the basis upon which HTML has been defined. All of these communicate via HTTP with the server. The server in our case is an Apache server running PHP as its language. The PHP server is communicating with many things itself, including databases, including its own local file system, and maybe even remote services. That is to say, the server itself can make API calls to remote servers in the same way that a client can. Model view controller is one way of effectively connecting all of these different disparate parts. Does that make sense? So far, so good? So, model view controller is a design pattern. What a design pattern is it's a known approach, a well-described approach to solving common problems. From a sort of highest level perspective, what you do when you're using design patterns is you are constraining the way in which the program can be built. You are saying to yourself, okay, this is going to do this, that is going to do that, and I will try within the bounds of reason to preserve these relationships. Especially when we are working in a lower level language like PHP, that is like a base language that the server is running on, it is totally 100% possible to violate MVC architecture in many interesting and creative ways. Perhaps even inconvenient ways. But one of the things that MVC provides is a universality of interface which allows for the ability to essentially bolt more components, bolt more procedures onto the side without having to modify the rest of the code too heavily. The more that you depart from MVC architecture, the harder it becomes to keep your program up to date, and the harder it becomes to add new features. Maintenance becomes more and more of a chore the further you get from MVC, or any design pattern. So, the design pattern is also a way that we are taking the problem of running a web application and decomposing it into its parts. Remember that the decomposition of a problem into parts is it's an absolutely fundamental skill in software engineering. It is perhaps even the only skill in software engineering. Everything else is syntax, right? What are we doing when we write a program? We are taking a mathematical operation, decomposing it into individual programming language statements, and then executing those in sequence. We are taking the problem, breaking it into parts, solving each of those parts simply, and composing those small solutions into one large solution. That is software engineering in a nutshell. Well, it's not only software engineering. I would venture to state that that is how engineering in general works. If you wish to solve a problem, you take that problem and you just decompose it into small pieces, solve those pieces, and put the solution back together again. So, there are several benefits to using design patterns. One, they allow different developers to work independently on different subcomponents. Once you have taken a problem and decomposed it into smaller chunks, it is then feasible to assign different developers to those different parts. One way that I've talked about doing this up to now is the difference between the front end and the back end of a web application. What are the front end languages again?
Front end?
Front end.
JavaScript.
JavaScript, CSS, and
HTML.
HTML, very good. What are the back end languages we've talked about so far?
Is it PHP?
PHP, and I would throw SQL in there. Since the client isn't really talking to the database, we can count SQL as a back-end language. So it is reasonably easy if let's say you're working in a team with 2 people, right? You can take a web application and slice it right down the middle. One person does the front half, the other person does the back half, right? Easy division of labor. In that case, the way that you're dividing the labor is even, like you aren't even working on the same programming languages, right? And this is actually a very, very typical way that things are broken down in industry, right? To the extent that front-end developer is a job title, back-end developer is a job title, right? Companies will hire you specifically for your skill in back-end development. Now, you also have full-stack development, which basically means I know and can do both front and back end, but typically, unless you're the only person working on a project, in practice, you'll be doing one of the 2 of those, even if you're qualified for both. Right? That makes sense, right? So, you can imagine it, breaking down even further. Let's say there were 3 people on the team, right? Maybe you would have one person do HTML and CSS, another person do JavaScript, and another person take care of the server. I would say that generally speaking, the front end is more work than the back end. So having 2 people on the front end, 1 person on the back end might even work. You can even find, since the development of Node.js, there are even server-side frameworks that use JavaScript as the language anyways. So a person with expertise in JavaScript would be able to more effectively move to the server and maybe help out a little bit there as well. Although, you still have to know how a server works, right? So this division of labor is not just between different languages or different technologies, although that is, probably, like, that's one of the most obvious divisions, right? Like we've been talking about 1, 2, 3-person teams. What if you had 100 people working on a team for a website? This would have to be quite a major website, right, to have 100 people working on it. I don't know how many people work at eBay, but like if you think about something like eBay, right, you're kind of getting into that territory. It's no longer adequate to simply divide roles among different programming languages. You now have to divide roles among subcomponents within a programming language, right? You have to take your software architecture, split it into components, and say, okay, Johnson, you're responsible for this set of functions. Okay, whatever your name is, you do these other ones. So, using version control software, the purpose is that, you work on your files which contain code, I'll work on my files which contain code. We'll keep, out of each other's hair, and then we can pull the whole thing together into one whole that works. But the problem with that, the problem when multiple people are working on the same program, is that people need to have a fixed interface between these two areas of software, right? So essentially, let's imagine a situation, right? Let's say that one of the divisions in our software project is you are responsible for writing some functions and you are responsible for using some functions, right? Doesn't matter what the functions do, but you're writing the functions and you're using them to make like a user interface or something, right? When you write a function call in your program, you are expecting certain things to be true. You are expecting the arguments to be this, that, and the other. You are expecting the return value to be a specific thing, right? That is the interface. That's also known as the API, Application Programming Interface, right? So if you, for whatever reason, say, you know what, I've been writing this function, but I really don't like the way that the inputs are, I'm going to rearrange the inputs so that it is a better function, right? If you do that, you're going to break his code, right? Your code has assumed, let's say, function foo takes an integer, a string, and a double, right? If you say, oh no, integer, or a function foo needs an integer, string, a double, and a boolean, your code, you don't know that that decision was made. Even with the clearest of communications, this is, it can catch you on the hop, right? So you've written your code to take the 3 arguments. You change the code so it now requires 4, your code breaks, right? And you don't know why. And then you look into his code and say, oh, that argument wasn't required before. It would have been nice for you to let me know, right? And that's a process that can take time, because it's not always obvious what is causing a bug, right? So, generally speaking, when we are working with multiple people on a software project, the most important thing is that we agree upon what functions are available, what they take, and what they produce. Yes?
I have a question. Does this problem often happen when they're using multiple languages, or is it even in the same language?
Even with multiple languages, this can be a problem. So I'll give you a good example. Let's talk client-side, server-side, right? We know that the server receives certain types of inputs from the client when the client makes a request, right? For example, you guys have done assignment 3, right? So you've done a little bit of like sending form data back, right? So let's imagine, just for the sake of argument, the person who's doing the client side decides arbitrarily they want to put another question on the questionnaire. So they attach that additional question information to the request packet. Well, the PHP isn't trained to pick it up, so it's going to ignore it. So the data is collected but lost, right? This is like a less bad but still bad outcome, right? It doesn't break the program, but unless there's consistent communication between the person in the front end and the person in the back end, you know, information is being lost, perhaps important information. On the other side, if the server side, if the person programming the server decides, oh, you know, I was requiring these 3 inputs to do the thing that I was doing. Now I'm deciding I want a 4th input as well. That is going to break the client, right? The client doesn't know that it needs to provide that 4th input unless it's told. And even if it's told, this has been baked into the software in many, many places, right? So fixing it consistently is quite the task, right? Even with the best find and replace algorithms, it's difficult, right? And by the best find and replace algorithms, I mean like just find and replace. As programmers, find and replace is like your best friend. Learn to use it. So when we create, yes, that's okay. So when we create a relationship between client and server, we are also creating an application programming interface. The only difference is, instead of it being a function call, you know, you write the function, you call the function, now it becomes servicing HTTP packets, right? You send an HTTP packet, you process the packet and return the result, right? If the inputs that are attached to the request are not recognized by the server, it's not like it'll fail to compile. Like it wouldn't, like in the previous example, if it were C#, it would just not compile, right? In a web server, it's not that it will fail to compile, it will just not do what you want it to, right? For example, maybe it just fails to load the data from the database, right? But you know, failure to load the data from the database in a social media application means that the end user is like, where's my feed? This is broken. I'm going to use the competitor, right? So you know, in the medical field, you probably have less to worry from competition, but nevertheless, does that make sense? This actually gets even more explicit a bit later on when we start talking about things like REST APIs. Up to now, when we've talked about PHP, right, we are either giving a full web page or perhaps some JSON, right? But the request is being made usually from like a URL or a link or something, right? Once we get into web APIs, we are no longer even interested in the client necessarily having a browser attached, which things start to get interesting. So, for example, let's consider a medical devices application, all right? Let's say, just for the sake of argument, your task, and this is a realistic task for you folks in this discipline, right? Let's say that your task is, we have a new system For medical monitoring device. What's a type of medical monitoring device in a hospital?
The ECG device for the heart?
Sure. Let's do ECG devices, right? It would be useful, if an ECG machine, detects that someone's heart stops, the machine presumably will start screaming, right? In the room, though, right? Wouldn't it be convenient if a patient's heart stopped, that some record of that will be sent, to the phone or device of a doctor who's like, oh shoot, the patient in room 37 is dying, I have to go, That would be useful. Some kind of modern paging system. So how would you go about setting a system like that up, right? Previously, people did this with telephones, right? You would have to have a doctor paged, right? Intercoms, that sort of thing. These days, this is what you do. You have the ECG machine communicate with a server. The server then issues alerts, servers can't issue alerts. Basically, the doctor's phone checks with the server once every 2 seconds or so to see if there are any alerts for it, right? Because communication always starts with the client, right?
And do you connect your phone with the device and the phone so that when the alert happens, it goes to the phone and also all the data is saved to that phone?
So, 2 questions. On the first, can't we connect the server directly to the phone? That is what I just described, actually. Using HTTP, right, using internet packets, the client must always initialize communication. So the server has no physical capability to push to push information out to a client. That's just not how client-server architecture is made, right? However, if the client is checking with the server sufficiently frequently, it doesn't really matter, right? It's does it matter if does it matter at a McDonald's if they bring your food to you, or you go up to the counter to check to see if the food's ready every 2 seconds, right? You'll get your food just as fast either way, right? So, to your second question, would the doctor's phone have information aside from just the alert, right? Yes, absolutely, right? What would happen, the doctor's phone might not carry that information in its own hard drive, but that information would be easily and readily accessible using another request, right? There's really no reason to keep that data locally on the doctor's phone if so long as communication with the server is, reliable. Now, is server communication always reliable? No, right? So in that case, if it's something very important, you might include a backup system where, your doctor has a tablet that has digital charts, and those charts are, a local copy of those charts are kept up to date with live information. As long as this connection to the server is live, it's kept up to date. As soon as the server connection fails for whatever reason, you still have the local copies of the charts. They're not updated through the automatic mechanism so long as the system failure is active, right? So you want to keep your server uptime up as much as possible, right? Especially when this type of thing is relying on it. But so let's go back to our ECG machines, though, right? Does an ECG machine have a web browser?
Yeah.
Could you load Google on one? Probably not. That's probably not something you would even want, right? For one thing, general internet traffic can contain viruses. And you really we don't like viruses in patients. We particularly don't like viruses in medical equipment, right? So all of this stuff that I'm talking about, that would be kept inside of the hospital's local area network. It would not be given exposure to, the general internet. Maybe in some kind of controlled fashion, where people could communicate between different hospitals important information. There are ways to set up secure networks between specific endpoints, but you wouldn't open it up to the internet, right? So in our ECG machine, it's a machine that wants to communicate with a server, but it is not expecting a web page as its result, right? The purpose of the sensor really is just to keep pushing information to the server. Maybe there's some kind of system where the doctor presses a button that says, "I'm on my way," and then a little indicator comes up on the ECG to see that, someone is on their way to help this person with their current cardiac arrest situation, right? Maybe you could conceptualize some kind of system like that where the sensor also does a little bit of, viewing data, right? But it would be minimal. It would be minimal at best, right? It certainly wouldn't be an HTML page, and it certainly wouldn't be JavaScript or CSS or anything like that. So this is a concept generally referred to as the Internet of Things, right? Which you guys have probably heard of,
Yeah.
and you probably have courses on coming up, right?
No, we already took it. Networking.
Oh, there you go. So basically, when you're talking about Internet of Things, you're more talking in the neighborhood of REST APIs rather than sort of traditional file requests as Web Classic is. The internet in general is kind of moving in this direction gradually over time as well. So yeah, a REST API call looks and feels much more like a function call in something like C# than it does all of this web server stuff that we've been doing in this course so far. But the technology we've been doing in this course will, by the end of this course, enable that. So we're making our way there. But yes. So anyway, so REST APIs, APIs between client and server, APIs between components of software within the same programming language, provide a common standard to communicate about problem solutions and software architectures. We want our software communicating using a common interface. As you progress as a programmer, you will increasingly encounter and work with design patterns. MVC is perhaps the most widely used design pattern. There are, other opinions are available, of course. Or I should say other design patterns are available. But basically, the further you get as programming, the more likely it is that people will give you actual real problems to work on. And when you are working on real world problems, you need real world solutions. MVC architecture being one of those. So, the MVC architecture stands for Model, View, Controller. This splits the application into three main sections of concern. The view is the user interface. It's what the user views. In our context, this means that HTML, CSS, and JavaScript are all parts of the view. The view for us means the front end. We then have M, the model, This includes database access and business logic. It's a little bit of a loose term, business logic, but it basically means everything the program calculates that isn't part of the sort of taking inputs, deciding which function should be called, all of that kind of stuff. So to take an example from a previous assignment, in assignment 2, you guys remember assignment 2? You did a front-end form, right? There were a bunch of if statements inside the JavaScript that gave descriptions of the various ailments a person could have based on their selections, right? That part, the part where you have the if statements, based on what was selected, you might have this, that, or the other, that is business logic in that context, right? The part where you are reading the inputs from the form, the part where you are putting the outputs back into the HTML, that would be controller stuff within the context of assignment 2. So the controller controls communication between the model and the view. It actually doesn't do much more than that. It's controllers are also sometimes called routers. Any questions? So far, so good? Good. So, this is your view of model, view, and controller. So, within the context of a PHP application, our incoming HTTP packet arrives at the controller. This is the first step in the PHP, right? The controller receives the incoming request packet, finds out what the inputs are, finds out everything it can from that input packet, and then selects something in the model to execute. Maybe we're trying to update a database record. Maybe we're just trying to read the database. Maybe we're trying to register a user. Maybe we're trying to log in a user. Maybe we're trying to establish a session. All of that stuff is model stuff, but you don't know which of those operations you want to perform without the controller reading what's in the packet. Does that make sense? Any questions? So, once the model, the appropriate functions in the model have been called, they produce data. That data is then taken back up by the controller. A decision is made about the data returned from the model, and an appropriate view is then selected. That view is then populated with the information from the model, returned to the controller, and sent back to the user. Let me run you through an example of that. Let's say that our website requires login. Let's say that the user is on a login page and makes a request to log in, right? What information would be attached to the request in this case if the user is attempting login? When you have to log into My Mohawk or My Canvas, what do you have to provide?
Student ID and password.
Yep, a student ID number and a password, or username and password. So the request from the client to the server will have username and password attached, right? Next, the controller receives this packet and recognizes it as a login request, right? It it then says, okay, this is a login request. Okay, model, I want you to take this username and password, tell me if they're real. It sends the username and password to the model. The model consults the database, right? It says, oh, I see. Username is frogs, password is more frogs. Okay, let me look at the database. Thumbs through its Rolodex, thumbs through its Rolodex. Oh, I didn't see that username and password combination. I'm sorry, that's not a real user. It says, not a real user, back to the controller. The controller then says, oh, not a real user, you say. Okay, view, please give me the page that says you suck. Because you can't remember your password, right? So the controller says, okay, in more formal terms, okay, view, we've just received a bad login attempt. Can you please look up and find the web page I'm supposed to show when there's a bad login attempt? The view is like, oh yes, here it is. Here you go, I'll just fill some data in for it. Here you are, controller. Controller says, oh, thank you ever so much. I will send that to the user, and it does, and you get your failed login attempt page. Conversely, if your credentials were good, username and password come into controller, get sent to the model. Model checks database, finds username and password. Good, sends login successful to the controller. Controller says, okay, login was successful, view. Which page should we show then if the login was successful? And view says, here is the dashboard page. Dashboard page is returned to the controller and then returned to the user. That is how a modern web architecture works. Does that make sense? Cool. So, benefits of model view controller architecture. Developers specialized towards front-end code can modify view files without impacting business logic. Believe me, you probably don't want people messing around in the business logic. Developers working on the business logic can modify the model without impacting the user interface. So, you may have noticed that the different aspects of web development require slightly different skill sets, right? If you are a person who produces good and interesting designs, visual designs, there's no space for that in server programming. If you're the kind of person who is an insufferable nerd and doesn't really even like humans that much but loves code, then you're probably a server-side programmer, right? Because you don't really have to worry about how human beings are going to interpret your work. All you have to worry about is, I am doing the math operation. Here is the math, here is what I'm doing. There you go. Mathematics. So, different people have different skills, and this architecture helps people work to the best of their abilities. So, if multiple people can work on something at the same time, this allows for faster development, which means that you can get your product to market faster than your competitors, which is always good. Extensibility. Views and models can be interchanged, modified, added, subtracted easily because everything is modular to begin with. Multiple views for mobile and desktop is one way of going about it, although of course this is an older approach. These days we want responsive designs that look good both on desktop and mobile. Back in the day though, they used to do a completely different version of the website for a phone, right? Some of you probably remember, websites that looked absolutely awful on phones. Yeah? Basically, yeah, anyway, that's a digression. I'm not going to go on it. So imagine 70,000 lines of HTML, CSS, JavaScript, and PHP mixed up together, noodled together by one person. It's just going to be a mess. The locations of bugs are more quickly identified and fixed when you have separated your concerns. For example, if you are getting a database error, you can look in the code that deals with the database and not all of it. If you are, if you have a problem with the login page, you can just look at the login page, which is a view. Virtually all PHP frameworks use MVC as a foundation or have it as an option. Laravel is the one we'll be discussing in class, but CodeIgniter is another one. However, and this is what we're going to be doing this week, in order to understand the principles of MVC architecture, we are going to build one in plain old vanilla PHP. We're going to take regular PHP, we're going to build what's called a switch controller. It's called a switch controller because at the center of it, at the very beating heart of it, you will find a switch case. So, basically, we're going to learn how to drive manual before we learn automatic. We're going to see how all of these various pieces are constructed and put together before we go any further than that. So, as stated previously when I was talking about design restrictions, MVC architectures, their value is derived from the restrictions that they place on design. When we use MVC, we are doing things in one specific, particular way, and only in that way. If we start having the view do things that only the model should do, for example, calculations or accessing the database, we have broken the pattern. If a developer needed to fix that calculation, they would be even more confused if no pattern was used. It would be even more confused than if no pattern was used. So if you're generally following MVC architecture, and then for whatever reason, you have like view 370 doing database stuff when it shouldn't be, somebody who has to fix it will be looking in the wrong spot for the bug, right? They'll be looking in the model because that's where that stuff is supposed to be. And it will probably take them quite some time to find this misplaced database access inside of a view where it's not supposed to be. So, as a result, the descriptions for how to implement MVC in these slides are more than guidelines. They are quite strict requirements. Any deviation from these requirements, even slightly, is breaking the pattern, and marks will be reduced, deducted. So you have to follow the pattern, okay? Any questions? Okie dokie. So, let's decide on the character of a running example, all right? So we want to build a website. Perhaps, do you guys want to do the login system that I was talking about? That seems reasonable, right? That will actually set us up well for, I think it's next week when we do sessions. Let me take a look, see when we're doing sessions. Yeah, sessions are next week. So there are some client-side considerations when you're doing a login system. In order for a person to be truly logged in, the browser has to have a cookie that says you're logged in, right? We're going to learn how to do that next week. For now, let's just worry about users being able to check credentials, right? So we'll do the first part this week, we'll do the next part next week. So, so we need a credentials database, that much seems clear. Within this database, let's define a few basic operations, right? First, it's not much of a login system unless you have a login operation. But it's also useful to have users in your database. So, let's also do a register operation, and let's do a deregister operation. Make sense?
So it can be all in one page? Or like
Yes.
if you don't have an account to register? Yeah.
So that's kind of, we're going to start off, I think, with all three of these on the same page. But later we can split these into multiple views. But for now, keep it simple. Yeah. So, if everybody could please load their code editor of choice, we'll get to programming. Someone was using this mouse with sticky fingers. Okay. So, for the moment, let's make an HTML page which presents the front end for this. Let's not worry about PHP first, let's have some kind of front end to work with, all right? So, let's see here, my websites. Where is everybody, by the way? Do you have any idea?
I'm not sure. Even last Wednesday, the numbers were low, but I'm not sure right now.
Yeah, it's like, I know I record the videos, but like class participation is best, you know. Okay, so let's call this view.php. There we go. So just because we call it a PHP file doesn't mean that it contains PHP code. Basically, by calling it view.php, I'm leaving the option open for integrating information later. Does that make sense? So, let's make ourselves a little HTML page. As with all PHP examples, this will be an extremely stripped down HTML page. So, we need a couple of forms. Since of these three operations, we need to have users registered before we log them in or deregister them, let's make our first form the registration. H2, register a user. Now, we want to make a form. But that form needs to call a PHP script as its action. If you recall, the controller is the part of the MVC architecture which receives all incoming packets. Right? So, in all cases, the PHP script that we will be targeting will be controller.php. Does that make sense? So, we'll need a couple of inputs as well. Type is text. Name is username. Break. Input type is text. Name is password. Break. Input type input. There we go. Type is submit. Value is register. There we go. Make sense? So, we have our view. Oh man, I forgot to fire up XINF. All right. Sorry, folks. If we could please also launch XINF. There we go. Very good, very good. Start your Apache and MySQL servers. And many apologies, but if we could also copy the work that we were just doing into htdocs, that would also be excellent. In fact, that would be the only way that this works. There we go. Paste. So, view.php. So, if we go to localhost, we can see our view file inside of htdocs. If we click on view, here's our registration. Currently doesn't do anything. In fact, if we fill this out, we get a 404 response. Right? Controller.php does not yet exist. So, basically, we need the controller script. So let's create one quickly. Oh man, did Notepad++ close as well? What a pain. There we go. Make sure that you're launching it, make sure that you're modifying the version contained in htdocs. Let's make a new one. Save that. htdocs, yes. Call this controller.php. There we go. Now, here's the other thing though. What we just did is actually like not really the correct way for MVC architecture to be used. We shouldn't access a view directly. When MVC says that all incoming packets need to be routed through the controller, it means precisely that. All incoming packets. That includes clicking links here, accessing through the URL address bar. Everything should come through the controller. So, the controller needs the ability to display the view. Currently, it contains nothing. So, there is a very handy, very nice statement that you can use to get one PHP file to show up inside of another one. You'll need to be in PHP mode, of course. That is include. It's include view.php. I got that wrong? Is it like this? There we go. Sorry, it's a function. Sorry, my brain skipped and I was using C syntax rather than PHP syntax. There you go. Include view.php. You can notice that although we have access to controller.php, we are viewing the view. Make sense? So far so good? Do you guys get that working? Still working on it? Is a question about your code?
So I got it down and then save the HDocs Excel and have this running. But whenever I open it, it just opens like it doesn't show this one. This one.
Oh, if I might just move your bag. Where do you think it is? No.
It's above.
This is the version though. That this version, like this is the one you've been editing, right? Got two instances, right? Why is it two? Strange. All right. I would recommend making a folder for this. Which one of these is correct? That would be the reason. Yeah. Did you get it work?
No, still on this.
Hurry up. So. the ability to send information to the controller. Oh, one thing I should note though, even though this is just kind of a in-class example, do we send user login credentials via GET, encoded in the URL? No, it is publicly accessible. So, the method will be post. There we go. So, we now have the ability I will need to reload the page to get that to work. We now have the ability to send these credentials to this script. However, the PHP script currently ignores any input that it's being given from the client. So, the next thing to do is to read those inputs. We'll do this using the traditional method in PHP, which is using filter input. User is equal to filter input underscore post. The name of this field is username. The actual filter, because this is a string, is filter sanitize special chars. The same is true for password. There we go. We of course need to distinguish at this point between reading our between the different outputs that filter input can give us. So, because this is a string sanitization filter, false is not an option for a return value. That's only true for validation filters. Here, we have to worry about situations where username and or password are null. Can anybody remind us why the result of filter input might be null? What situation does that correspond to? When filter input is null, what does that say about the input that we are reading? It means that it was absent. There was no input that was included. So, okay, if there's no input, previously we considered that an error, right? But now, a request to controller.php could validly exclude username and password. This is actually the precise situation that you're in when you load the page from the URL. The initial load does not have any parameters attached. So, we must detect them, but this is not, we are not in an error state if username or password are null. So, if user equals null or password equals null, if these are the case, we actually just want to view the view. Otherwise, we want to check the login. Or not check it, login, register user, pardon me. Does this make sense so far? So far so good. Yeah?
You quote password, set writing class. Is that correct?
Oh, no, I'm sorry, yeah, that's an error, thank you. The point I'm trying to make here is that these are the names these are the names that we received from the HTML form. The variable names in PHP are not necessarily the same. Yeah. Good. Thank you. So, so the next thing that we should do, I think, we should start a model. We should start working on the database, since now we have some information to send to it. Make sense? So, in order to do so, let us create a new file, save that as model.php. Model.php. Now, before we do anything else, except maybe add the PHP opening and closing tags, very important step, the model needs to be included in our controller, otherwise none of the model functions will be available. The model is not intended to execute any code itself. It is merely providing function definitions. Maybe connection, maybe it establishes the database connection, but that's as far as it goes. So, up at the top, include model.php. There we go. Now, within our model, we know what the three operations that we wish to perform are. So, we can go ahead and lay in those functions. So, function, register, function, deregister, and function login. Register, deregister, and login. So here's a question for you. What information is required to register a user? What do we need to know? The username and the password. Very good. So we should provide that. What information is required to deregister a user? No, it needs remove the entry from the registration database entirely. So this one's a bit of a design choice, right? So it depends on what types of assumptions you want to make. If you are assuming that the user can deregister themselves, but they have to have a valid session, like they have to be logged in. If you're logged in, you can deregister yourself, right? In that case, we actually don't need any information here to deregister. If you assume that the user must enter their password in order to delete their account, they must be logged in but must re-enter the password. All that's required here is the password, right? But because we're not doing sessions yet, let's assume that the user must have, let's assume that the user must enter a username and a password, both of those, to re-register their account, just because we're not doing sessions yet. Sound good? So actually, deregistration will require both username and password as well. And of course, what do we require to log in? The same, username and password. So, it's at this point that we might consider jumping over to our SQL database and setting that up, since we will need to be connecting to it very shortly. Ugh, pardon me. Oh, calm down. So remember that you can access the SQL administration from XAMPP using the admin button. There we go. Let's create a new database. Give it a name, oh, I don't know, login. There we go. We will need a new table. Let's give it number of columns. Oh, let's just keep it extremely simple and say 3. Table name, credentials. Go. For the credentials table, let's establish an ID, auto-incrementing primary index. There we go. Let's have username, and let's have password. Username and password, we'll make those both varchars. Size 32 should be fine. There we go. Please take a moment to make sure you get these settings down. Do you want to see the other one? Model? Come to class. All good? Got it? Got it? Cool. So, if we create the table, save. There we go. We have our credentials table with nothing in it. Our next objective is to connect our model to this. We need to establish our database connection. So, best thing to do in this situation is to go take a look at some of the code previously published. There is absolutely no need to reproduce this code from memory. I would never expect you to do so on an exam or anything like that. It's just standard connection boilerplate. So, let's see. Oh, that was the review. Yeah. Did I fail to post it? That seems unwise. All right, second plan. Let's go into the modules. Let's go module diagram. Also, we have to do we have to introduce assignment 4 today. Yeah, we have to introduce assignment 4 today. There it is. This is the code. So, our database name is not hospital. We called it login. But other than that, this code establishes a connection to the database. Sound good? if we can run our code without getting the connection failed message, we can be sure that we connected successfully to the database. Sound good? If the connection fails, we also won't get the login page. So, let's take a look. Well, let's just access from the URL. There we go. So far so good. Very good. Any questions so far? So let's take a break out from this and let's discuss assignment 4 then, shall we?
Can you open it so that we can see it? 'Cause we're not able to see
Oh
it.
yes, don't worry. In fact, maybe I'll just release the rest of them so you can see them. Hello, welcome. You're just in time for us to discuss assignment 4. So, in this one, there is starter code. So please download the starter code, as that will help move the files app.control, app.view, and app.model, app.config to your XAMPP installation's htdocs folder. Navigate to localhost/phpMyAdmin in the web browser. Click on the phpMyAdmin logo in the top left corner. Yes. Import. Yes. Instructions on how to set up XAMPP. Sure. Add the following CRUD database features to the behavior tracking application. These features must be implemented using model view controller pattern as discussed in class, respecting the role of the model, view, and controller, and the expected way in which communication is to occur. That is, you must use a template array, which is a thing we're going to discuss in class shortly. Each of these features is a variation on a CRUD database feature we have already implemented together, so try to use those examples to help with implementing these features. So, the operations which you are supposed to create a severity, so basically this application contains a list of patients with certain data. One of the columns is severity. There are clickable up and down links. When the user clicks on the up link, the table should be sorted in ascending order according to severity. When they click on the down link, it should be sorted in descending order according to severity. This means that you're using an SQL query to gather the data that now uses order by ascending or descending. Yes. References provided. Create a delete all button that, when clicked, deletes all behaviors from the table and reloads the page with an empty table. Lasted greater than 1 hour. Create a new column in the HTML table with the heading lasted greater than 1 hour. Display the currently unused lasted hour field value in this column for each record in the table. Whenever a new behavior record is created, the value displayed in this field should initially be no, but there should be a clickable link. So basically, in this one, you are required to modify the model to accommodate one additional field defined in the database. Duplicates, create a column in the HTML table with the heading duplicate. In each row of the table, there should be a clickable link, which will give you a copy image or text, like duplicate, something like that, in the table itself. When the link is clicked, a duplicate record should be created and presented in the table on page reload. The duplicate record should have all the same field values as the previous, except the ID, which should be unique. You will need to edit the files app.control.php, view, and model. So you're not making your own new files in this one, you're editing ones that have been given to you. Do not modify database table structure as part of the assignment. The columns and types should all be the same. Submit these PHP files and any other solution files, like app.config.php, which you might put your connection data into, and any image files that were used. Submit your solution file in a zip file and send it off. So here you go. This is what you're being marked on. 20 points for your severity sort. 20 points for delete all, which is actually probably the easiest of all of these, to be honest. 20 points for lasted 1 hour. 20 points for duplicate, and 20 points for not horribly violating the model view controller pattern. By the end of today, we'll know everything. By the end of tomorrow, at least, we'll know everything. You'll know everything you need to know to do this assignment. But let's take a look at the due dates, because I think the due date for this is possibly not accounting for when we had the midterm. So let's see here. We have, this one is due April 23rd. Next one is due 2 weeks from then. Next one is due the week after that. So, unfortunately, the timelines are a bit tight, but I think we have to stick to that because.
Can you just make it PM instead of AM?
Oh. Yeah, where is it here? Wait, did those actually publish? Here. Let me see here. Well, if I'm, oh yeah, it's AM instead of PM.
There's no way we can extend the time for that.
See, the problem is the next one is coming hot on its heels. I'll tell you what. I'll give you until Wednesday. Okay? I'll split that week for you. But if I give you much more than that, then it just crunches into the next assignment. If you want my honest opinion, I think this course has one too many assignments. But, you know, it's kind of beyond my ability to change at this point. Also, like, we kind of got a little bit put in a difficult position because if you remember the very first week of class, Monday was like the day off, so we missed basically the entire week of class. We didn't really start until week 2, right? So, you know, things have become a bit of a crunch. But unfortunately, there's nothing really I can do about it, you know. Aside from try with all my might not to have a cold on a Monday for the rest of the semester. So, good. Any questions about the assignment?
I just didn't understand. Are we going to be using SQL as well, or assignment form?
Yeah, let's take a look at the starter code. But yes, you'll need to write some SQL. Download. Download. There we go. So if we take a look inside of the model, yeah. There you go. This model contains all the functions that access and modify the database. So you'll notice that here, you're given a certain amount of code, right? You've actually been given like delete a single record, but that's not what you want, right? You want one that deletes all records, but you've been given something to work off here, right? Create record, like this does, this code, or this application does more than the specific functions you're required to implement. So there are functional code examples for, related operations that have been given to you. So hopefully this one isn't too bad. Okay. I would say that of the assignments you've done so far, if you're paying attention today and you get the material, this might be the easy assignment of the bunch. So that's my personal opinion. Whenever I say an assignment is easy, people inevitably come to me afterwards and say, "I thought you said it was easy." And I said, "No, I said it was relatively easy. Relative to the other assignments, I said it was easy." But yeah. So good. Any further questions about assignment 4? Okie dokie. So, where were we? Yes, databases. So, going back to our own code, we have the code which establishes a database connection. The next thing that we need to do is we need to fill out the contents of the register function. So, there's a very specific rule in PHP having to do with global variables. This is a global variable. The connection variable exists in the global scope. Within functions in PHP, you need to include global variables within the local scope specifically in order for them to be accessible. This is fairly easy to do. You just say global connection. There we go. In fact, that will be necessary everywhere, so we might as well throw that in. There we go. Now, we need to prepare our SQL statement. SQL statement. So, what SQL statement do we use to create a new entry in a table? Insert, yes. Do you remember what my advice was about insert operations? Go to the database, go to SQL, click here, get the template, copy that in. Make sense? Now, we don't have to provide ID, that's auto-incrementing, it's provided for us by default, but we do need to provide username and password. username and password are being passed as arguments to the function, here and here. So we can provide those there and there. Remember, very, very important, if you do this, like that, you are leaving yourself open to SQL injection attack. All right? It must be the question marks. If you do not provide the question marks, I will take marks off. Look at me, look in my eyes, look in my eyes. I will take marks off if you leave yourself vulnerable to SQL injection attacks. Okay? You've been warned. It doesn't say that in the assignment, but I'm going to do it anyway. All right? If you leave your code vulnerable to hackers, you will not get 100%. Okay? I'm saying it now. I'm waving my hands like this so you know I'm serious. Okay? I'm going to say it into the camera. If you leave your code vulnerable to SQL injection attack, you will not get full marks on the assignment. There we go. Now everybody knows. Or maybe I will also put that on the assignment. That might be wise as well. Assignment 4, edit. There we go. Bold. If you leave your code vulnerable to SQL injection attacks, ... comma, you will experience a reduction in grades. You have been warned. There. I will say that as strongly as possible, including using the strong tag in HTML. See? There we go. That is official. So, it's very easy to avoid being vulnerable to SQL injection attack. Just use the question marks and then provide the data when you're executing, and everything will be fine. So, this needs to get bound to a statement variable. The statement variable has the execute method. To that we provide username and password. Question? Stretching? Okay. Now, normally, this thing returns true or false on success or failure. We're not really expecting to hear anything back, right? We're not, this isn't a select query. We're not expecting any view of the database on this. So let's just leave it there for now, and let's see if we can register some users. User's name is Mr. Krabs. Password is money. There we go. So we get a blank page, but that's what we expected. If we take a look, yes, I'm sure, thank you, at our structure table. Where is the data? Browse. Ooh. Well, it seems we have a bug. Yay, we have a bug. All right, so when we have a bug, the most important thing is to go through your program and perform a program trace to see where the data went wrong. So, number one, let's make sure of the values of username and password. Oh, wait. I see the problem. Okay, I see the problem immediately. Do you guys see the problem?
Is it about
Nope, the problem is right here.
Oh, yeah,
We haven't actually called the function. Wah, wah, wah. That will help. Register. User pass. There we go. Now let's see what we get. Bonk. Refresh the page. Loading, loading, loading. Don't take too long. You took too long. Don't take too long. Took too long. Stop. Start. There we go. Databases, login, credentials table. There you go. Our data has been successfully entered. Very good. So now, we want to know if the database succeeded in this operation, and to use that information to determine what the view should be, right? At the moment, we're just assuming that it goes through, but there are many reasons that a database might reject an attempt to register a user. Can anybody think of a reason that a database might might reject a user registration?
wrong password.
Well, you're creating a new one, right?
Not reliable password. Easy to guess password.
Easy to guess password, yeah, that's one for sure. Another one might be that user already exists, right? So, we need now, basically we need an error page, right? But even before we have an error page, we need the ability to send back to the controller the state of things, right? Did this operation succeed or fail, right? Introduce the template array. The template array is an associative array where communication between model, view, and controller is kept, aside from basic things like function arguments. So, for example, you might not only want to say, oh, this page experienced an error, you may also want to know something about the error that was produced, right? So, a simple Boolean return value from the function is not going to cut it in this situation. So, the template array, this is an example of what one might look like, but it's by no means the only example. Essentially, you have a set of associations between different keys and different values. These are, of course, nested structures. We are essentially talking about JSON here, right? So the server in MVC is keeping track of an internal JSON array into which all of our important information is being placed. So we can create this in the controller. It's one of the first things we should do. TPL is an initially empty array. because this is in the global scope, it will need to be imported in the model using the global keyword as well, TPL. That will have to be everywhere. Hello. There we go. And into the TPL, we can put the success or failure of the operation that has just occurred. So, the return result of this is success or failure. If success, we can say TPL at success is true. Otherwise, well, I've done this example before, and the success is actually kind of redundant, so I'm going to simplify it a bit for you. If not success, TPL error is equal to true. TPL at error underscore message is equal to failed to register user. So, because these have been saved to a global data structure, we can use this information to control which view is being shown. But of course, controlling which view is shown, that is the business of the controller. So we pull back into the controller, and we're going to, let's just take this out for the moment. There we go. Once all of this is finished, if TPL at error is set and is true, then we want to do something like include error.php. Otherwise, we want to include the regular view. Though at this point, because we have more than one view, we should perhaps choose a name for view.php which is less generic, right? So let's call it login.php. We should close it. Open this in the thing. Ugh, pardon me. Thank you. htdocs, there we go. Rename this login.php. Or I suppose it was register, but that's okay. That's okay. Edit that in Notepad++. And let's make a quick little error page as well. And then we'll have a break. So, new file, save this as error.php. There we go. The error page will be an HTML page as well. So we can kind of copy over some of that. We don't need the form, obviously, but this should say an error occurred. Now, it would be very useful for this thing to state which error occurred. This is information we have stored in the TPL. We can very briefly dip into PHP, echo TPL at error underscore message, dip back out, and that will integrate it into our web page seamlessly. Make sense? So now, where are we here? If we go back to our login page, oh, syntax error. Uh-oh, controller line 21. I probably forgot a semicolon. Yes, I did. Wah, wah, wah. There we go. So we register a user. Let's say Patrick. The password is password. Register a user. We get the registration page back because, let's see here, going back here, taking a look, the operation succeeded. But what if the operation were to fail? One way we can induce failure pretty easily is by simply cutting off the server from XINF. It's going to take a little bit because the PHP server is sending us, there we go. Oh, well that's a different kind of error actually. Oh, that's a shame. All right, that's not the error I wanted. Let's see here. Okay, I'm going to modify the code here in the model a little bit. Let's say I misspelled the table name. We can connect, well, actually that would still result in, oh, this is harder than it sounds. Syntax error in the SQL statement. There we go. Insert into egregious syntax error. There we go. That should fail to process. Now, if we go back, register the user, there we go. An error occurred, failed to register the user. Very good. It's also possible, I believe, to get information from the server about why the thing failed. But for the time being, this is probably sufficient. So I'm just going to take out the syntax error. There we go. Put things back to the way I found them. And there you have it. Any questions? So I think we will have our mid-class break at this point. I will take the code that I've done so far and put that up on the announcements feed so that we can all start working from the same basis for the second half of class. Okay? Sound good? Okay, please be back here at 2:24. Thank you very much. Now recording. So we were talking about MVC architecture. We were just getting into some of the architectural details. The last thing that we talked about was the template array, how functions from the model can put information into the template array for use by the controller to decide what view should be shown, and by the views themselves, which may have information to display. For example, if we were creating, if we had some data to view from the database as a table, kind of similar to assignment 4, for example, we would have a function for reading a database table. The data that we read would be dropped into the template array. It would then be picked up by the view that shows the data, organized into an HTML table. Oh, and by the way, the code examples, this code that I've been working on in class has been posted to the Avenue announcements feed. Avenue? It was Avenue at McMaster where I used to teach. I mean, anytime I accidentally say Avenue, I mean Canvas. The Canvas announcements feed, the code is there, so please, if you could download that and open her up on your own machine if you missed some stuff in the first half of this class. So, very good, very good. So, up to this point, we have only had one form that can do one thing. We only have a registration form. We want login and deregistration options. However, once we get there, it introduces a problem. How do we tell what kind of action was requested? So, for example, let's say I want to add a deregistration script. Aside from changing the word register to deregister, what else can we change here? Everything still applies. So what happens if we attempt to deregister a user? For example, Mr. Krabs, password, money. We have clicked deregister. Let's see what happened in the database. Whoops. Look at that. We have duplicated the entry. Right now, the controller cannot tell the difference between reading, or it cannot tell the difference between registration and deregistration. We need to send some parameter that differs in these two cases, right? So, there are several ways to do this. One of these is to include query parameters inside of the action itself, like so. Action equals register. Here, action equals deregister. What we are doing is attaching additional query parameters to our requests so that there's something now that is different between the two different types. Just so that we can see this, I'm going to do a very naughty thing. Oh, is it called request? I think it's called request. Let's try. Line 7, you say, huh? Oh, yeah, of course, because I'm missing the semicolon, as usual. There we go. So, the request superglobal gives you both post parameters and get parameters. At the moment, we're using both. Query parameters in the URL are always get parameters, but our username and password are post parameters. So let's try to register somebody now. There we go. We can see action register, username, ASDF, password, ASDF. Worst username password combination possible. So, now we can take that action, we can parse it, filter it, and we can use it to make decisions. Action. We'll filter it in this way. Now, you remember me saying that what we were building here was a switch controller, yet we haven't seen a switch case yet? Well, folks, now is the time. Now is the time for our switch case to exist. Switch? What are we switching on, you may ask? We are switching on the action. Now, action, at this point, has one of three values. It's either null, because action was not provided, or it is register or deregister, because we haven't done login yet. So, we have to catch the case where action is null first. If action does not equal null, we do switch case, just like that. Now, inside of the switch, we want a case for every action that our form might produce, right? So, for example, case, register, case, deregister, break, break. I've put a couple of echo statements in there, just so that we can see how the logic is flowing. So, now, if we save, go back to our web page. If we click register, we get registered, deregister. Is this saved? Should be echoing stuff now. Action is not equal null. Oh, that'll do it. There we go. Ah. All right, registration, deregistration. Come on. Whoa. Goodbye. All right. So we know that action is coming in. Let's see if we are making it into the middle of this if statement. Let's see what action is. Am I printing anything at all? Oh, I've got it. as a get parameter. That'll do it. Yeah. It was looking for it in post. Oh, and they let me teach classes. There we go. That should help. Registration attempted. Deregistration attempted. So we have made it to the inside of the switch. So, you see, that is why when you're doing anything with coding, anytime you have laid in a major code construct, put in some print statements, stop, test it before you move on, right? Because some idiotic little thing like forgetting to switch post to get becomes a much larger problem later on if you've written 100 lines of code rather than 5 lines of code, right? So, test early, test often. Write your programs so that they are almost immediately testable. So, if registration is attempted, the thing that we want to do is this. So, we can copy and paste this code in. There we go. This was our old code that sent the request to the model to register the user. We should refactor it a little bit though. For one thing, so if we have received a request for login and either username or password is missing, it wasn't a good request, right? This is no longer the case, oh, we didn't receive, we didn't receive all of the parameters, therefore it must be the default page request. Oh, no, no. Now, we have a missing action to tell us that it's a default page request. We must take these parameters and create from them an error state. So, if username is equal to null or password is equal to null, that means that we have a login attempt, a registration attempt with no username and password, or username or password, pardon me. So, that's an error. TPL error is equal to true. And TPL error message will be registration attempts require both username and password. You nincompoop. There we go. Because this is apparently a very insulting login system. Make sense? Good. Otherwise, we proceed to the model. There we go. So, now if we register the user, it works. But if we so the problem that I have now is I have to modify the HTML to send, modify the form in HTML to send without the password. I can do that. Just watch. So to send without the password, you go into elements, right? This form, password, delete element. There you go. It's gone. No pass. Register. Error occurred. Registrations require both username and password. You nincompoop. Make sense? So now, when we receive errors, we are handling them much more gracefully than previously. Much more informative error messages. This whole same thing also applies in the case of deregistration. You can actually, if you've set up MVC architecture correctly, reasonably large chunks of code can be copy-pasted between different portions of the controller. This is one of the advantages. This is one of the reasons that you can work in MVC architecture more quickly than if you don't standardize things. So, to deregister a user, we need to read the inputs in the same manner. Read inputs in the same manner. There we go. Oh, pardon me. There we go. The only difference here, is that we deregister rather than register. Deregister instead of register. Right? Of course, if we go to the model, deregistration has not been filled in yet. So, our next objective is to fill it in. Because it's good review of how SQL connections work, I'm going to go through it rather than copy paste it. Okay? So, our PDO connection object is created here in the global scope. It must be imported into the function using the global keyword. We are also importing the template array from the global scope. The next thing that we want to do is to prepare our statement. Statement is equal to connection, arrow, prepare. We then provide our SQL query. Now, in this case, we want to destroy the entry with username provided and password provided. Does anybody remember what kind of statement that is?
To destroy?
Well, to destroy a single record.
Select?
Select is view.
Delete, and then we're gonna say where and identify the record.
Yes.
Where ID equals.
In this case as well, I recommend going into here, the SQL pane in there, right? Click delete. Once again, it will give you a template, right? I don't think this one's nearly as hard to remember as insert, but the templates are there, so you might as well use them. I know there's a lot of information to absorb this semester from this course. So delete from credentials, where now we come to the filtering. We want to delete where username is equal to something and password is equal to something else. In the same way as we use question marks up here, we use them down here to prevent SQL injection attacks. We then use an execute statement to provide the parameters rather than splicing them directly into the string. Statement executes with username and password. The return result of this is a Boolean variable indicating the success or failure of the operation. Success is equal to statement. And from here, I am going to copy paste the rest, as it's just reading a Boolean variable and saying we failed to register or deregister the user as appropriate. Does that make sense? Cool. So, take a look at our controller. Very good. Let's run it and see how it works. So, register a user. Well, let me see, who do we have right now? We got a lot of blank ones. We could delete a few blank ones. Deregistered blank user. Oh. Undefined variable executed. Line 27. Let me see here. Undefined variable, my keister. Line 27. Execute. Oh, so another stupid little PHP rule. You include the $sign on the first variable, or the name of the variable, but not on the name of the method. So there you go. Lots of weird errors for that. There you go. Deregistration attempted. So we had 25 entries. Oh. And that deleted all of them that had blank credentials, which makes sense, right? That's the way SQL works. While we intended to delete just one entry, it actually deleted all entries matching that query. Which is right, because there were a bunch of blank entries anyways. Make sense? So far so good? Okay. So, finally, let's create, let's do a login. All right? Now this is not the, this is territory where there are very correct procedures which we are not going to be following because A, we haven't done sessions, and B, we haven't done password hashing, which we might get to if we have time. Password hashing is very, 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 very important. So let's create another form element, this time for logging in. So let's go to our login.php, create another form, maybe put this one at the top. Login. There we go. Action will be login. There we go. We've just created another form. Save. Now, we need to go into our controller and handle another case for login. Because of the way that we've set up the architecture, we can add this entirely new feature just like that. 1, 2, 3, 4 steps. Not counting documentation. That stuff wasn't important to actual execution, so it doesn't count towards the count. There you go. Of course, going to our model, we of course don't have the login function filled in, right? This one's a little bit different from the last two because we expect some form of data back again, right? So, we can still create our statement, preparing a statement from the connection. This time it's going to be a select query. We want to select as many entries out of the database that match our username and password. This is, there are two ways you could go about this, right? One is infinitely superior to the other. The first way that you could go about this is to load the entire contents of the credentials table into PHP and then look through it in PHP for the value you're looking for, right? Problem number one, way too much network overhead. You can imagine if you have millions of users, you can't have PHP download the entire table each time. That would be ridiculous, right? Each login attempt would cause megabytes and megabytes of data transfer, which would be awful. Second reason that's a bad thing. Databases are highly optimized for search operations. Your PHP code isn't. You are going to be searching that data far slower than the database could. So let the database do its job. Its job is to look stuff up, use the database appropriately. Okay? Sound good? So, select star from credentials where username is equal to question mark and password is equal to question mark. Now, in this case, we're actually not particularly concerned with the contents of the record. We already know the contents of the record if it exists, right? It's the username and the password. We already know that. What we are concerned with, do we get any hits on this at all? If we get 0 records returning, that means this username and password combination does not occur in the database. So, that's a login failure. If we get exactly 1 username password combination back from the database, we do have a user with that username and password, so that's a successful login, right? If we get more than 1, we know that we've configured our database incorrectly, as we have in this example. No 2 users in any credential system should have the same username. Usernames should be unique, right? Question, follow-up question. Should passwords be unique? Why? Or is that just like a gut feeling?
More like a gut feeling.
Or the uniqueness of somebody to, like if 2 accounts have the same password, it would be hard to tag into either one of the passwords.
Yes, but consider the process of creating those accounts to begin with, right? What happens if you're trying to register an account, say fake account 135, and you enter password, and it turns out that password has already been used. you now have information about other people's passwords. Right? So, you actually don't want to put a uniqueness constraint on the password field, because that gives too much information to people registering new accounts. There's another similar idea. When somebody fails on a login check, you don't tell them if it was the username or the password that was bad. Right? You just say credentials not valid. Right? And the reason for that, well, particularly you don't say, well, the password was correct. Password matched somewhere in our database, but the user didn't. You don't say that, right? But you also, you don't want to verify for a potential attacker that an account exists, right? Which is what you're doing if you say, well, that account exists, but the password's bad, right? Make sense? Like security folks, we are only just scratching the surface. Do you guys take any courses on cybersecurity at all?
No, we did a little bit and it's working, but it was just like intro.
We'll get into it a bit when we do sessions, but there's quite a bit in there, and I think that you guys should have more of it than you do, basically. Especially because healthcare is like a high trust environment, you guys really should be doing your cybersecurity and stuff. But, so it goes. So anyway, execute the statement. Actually, we can copy the rest of these lines. Boop. But we need an else case now, because this becomes some kind of unknown database error. But we now have to actually check to see if the login credentials went through or not. Did we get anything returned back? So, success, or is it statement? I think it might be. I can't remember. Give me 1 second. 1 second, 1 second, 1 second. I hate Windows. I hate it so much. Okay, it's from the statement. Okay. So, the statement stores the return result of the query. If we use the fetch all method, that extracts the return value of that SQL query, that which has been selected. Just to prove it, let's echo. There we go. Let's try it out. Log in, ASDF, ASDF, log in, there you go. Take a look. Those are all of the records in the database which match username ASDF, password ASDF. So, the thing that we now need to do is, we need to say to ourselves, how do we know if that has something in it? If we try a login combination which is not in the database, we get an empty list. So we need to tell how to tell the difference between an empty list and a list that's not empty. One way we can do that is using PHP's equivalent of dot length. Unfortunately, PHP being PHP calls it count. If count of fetch all is greater than or equal to 1, pardon me, we can set TPL logged in equal true. So once again, we are storing the end status into the template array. All communication between the model, the controller, and the view should occur inside of the template array. Sound good? All right. So, let's pull this over to the controller. So, if a user has logged in, they probably should not see the login page. We should have a separate page specifically for a logged in user. We could call it dashboard.php. They should only see it if they're logged in. So, if TPL at logged in, then we'll show a different thing. Include dashboard.php. We don't have a dashboard.php yet, so let's make a small one quickly. New, save, dashboard.board.php, and let's just put, it'll look a bit like the error page actually. Logged in. Now, at this point, there's really no point in doing logging out. The template array is not persistent between PHP sessions. The server has no way of remembering whether you are logged in or not. We won't get that until next week when we talk about cookies, right? So for now, there's no way for us to do a useful log out, so we'll just leave it for now. But we should be able to log in and see the login page now. Go. Undefined index, what did I call it? Oh, I know. Wait. Here we go. Controller, I forgot, is set. Is set TPL at logged in and TPL logged in. There we go. Log in. There we go. Good. Good. So if we log in with known good credentials, we are logged in. Very good. If we reload the page, or sorry, if we access the page again, we're back to start because, again, the server doesn't remember that we're logged in because we need cookies for that. If we don't log in correctly with fake credentials, login attempted, but we are still on our login screen. Does that make sense? Any questions? Good. Very good. So that actually completes this example. I'd like to, at this point, go through the rest of the slides to make sure we didn't miss anything important. And then, if we have time, we'll go back and I think, although this is not something that you would do like in a regular website, I'd like to show you how to like view table, like take a table in SQL and put it on the screen. Does that make sense? So let's take a look at our slides. So we talked about template arrays. The template array is how the controller will communicate with the view. The controller is responsible for setting the values of the template array. The template array is an associative array of keys and values, not unlike get and post superglobals. The controller might call model functions to help it do this. Yes, so when we call things like register, the controller is asking for the model's help in populating the template array. The view file will only read from the template array. The view file assumes that the values it requires have already been set by the controller. The view basically is assuming I am the last thing you do, right? Here is an example of a template array. So, view files are made up of HTML and CSS and some very specific types of PHP instructions. The PHP code in view files should only echo values. There should be no calculation going on inside of a view. This would be a misuse of the view because then it would be doing business logic. The view should get, all of its values from the template array and nowhere else. View files can assume that a template array is present and populated with the required values. So, there are three forms of printing stuff in a view using PHP. Number one, printing template variables. This is what we did inside of the error page. PHP echo TPL some value. All we're doing is we are reaching into the TPL, pulling out some variable value, and printing it to screen. Template switches. Essentially an if statement, which is embedded inside of the view. Now you may say to yourself, I thought you said there was no logic going on here. What's all this? Well, it's actually just a matter of, are we displaying something or not? Or maybe we are displaying between two different alternatives. We're still not we're still not performing any calculation. We are merely selecting what we are showing. Third, template loops. So, it will often be the case that the template array has something like a list or a list of lists, table data from a database, something like that, and you'll want to show all of it. A loop in PHP has the ability to show this information and be dynamic with the size of the thing it's trying to show. So in this case, we have a member of the TPL called data array. We have this for each loop, which creates one list item for every piece of data in that array. Make sense? Shall we see some practical examples? Let me just see how much more of the slides there are. Actions, yes. Well, we actually already covered that. That's good. Yes, good, good. Yes. Yes, we did that. Good, good, good. Yes, 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 yes. Good, okay. The rest of this we covered already in code examples. Okay, so with our login page, We need to gather up, well, before we even think about printing any data, we should go into the model and extract that data. So, let's create a new function inside of the model, model.php function. What should we call it? View or get credentials table. Sure. This doesn't actually require username or password. This, the assumption for this one is this will only be called by a logged in user. Because we can't verify that in code yet, we should comment that that's going to be the case. Should only be used by logged in user. Now, I don't mean this to sound like bragging, but that is a good comment. Okay? It is information that you would not have known otherwise. It's not explaining like what PHP is, right? It only adds value. And it's also short, compact, you can read it quickly, right? Sometimes people have a tendency to over-comment their code. You know, it's like, if you have a comment at the end of every single line of your code, you're doing it wrong, actually. Like, the purpose of commenting is not to tutorialize the programming language, right? You should always view the intended recipient of your comments as another person who is competent in the language that you are programming in, right? You should assume that whoever reads this already knows the language, right? Make sense? So, get the credentials table, very similar to this one. Main difference, we're just getting the table. We're not concerned about username and password. There we go. And we're not concerned about this. We want to store the contents of the table into the TPL. TPL credentials table. That we will use statement fetch all. There you go. This will assign all of the stuff that was found in the table to the TPL so that it can be pulled in the view. Where is the view? Error dashboard, that's it. So, now, we want to create, let's create an HTML table, because this is also how the assignment 4 works, right? We create a table. We can create table head and table head. The table will have all of the values in the database, ID, username, and password. TH and TH. ID, username, and password. Because we're now working with tables, let's add just a little tiny squidge of CSS so that the table is not really awful to look at, right? Add a head, Our HTML is no longer headless. Style and style. Table. TR? No, TH. There we go. Border. 1 pixel solid black. Bubble. There we go. Now, normally we would add an additional row using something like this. TR and TR, TD, value 1, and TD, value 2, value 3. Where these are the values which are pulled from the database. Now, we need to set up a loop so that PHP can loop over these values. Or, sorry, loop over all of the entries in the database. So, PHP for each TPL at credentials table. I think I called it credentials table. I never can quite remember. Credentials table, there we go. As data. PHP and squiggly brace. So, there is something very, very, very important to understand about the interaction between PHP and HTML. We open the PHP interpreter, close it on the same line. Within this line is an opening curly brace. This curly brace still matches that one, even though we're swapping in and out of PHP mode. So, you can connect up PHP control structures even if you're not in PHP, even if you are not continuously in PHP mode. Does that make sense? So this is basically saying, for each entry in the table, do this HTML. Right? So, we now can replace our values with further PHP statements. Data at ID. Data at username. And data at password. Looking good? All right. So now, going through to our, this guy. If we log in with valid user credentials, oh, we have a syntax error. Dashboard, line 17, okay. Line 17. Doo-doo-doo-doo. Oh yeah, well, that would be a syntax error if I forgot to close the PHP interpreter. Whack, whack. All right, try again. There we go. Invalid argument supplied for each. Line 14. Am I messing up the syntax? I think I'm messing up the syntax. capital E where it shouldn't have been, I think. Undefined index, oh, I did it again. Okay. So right now we're not loading any data, but there's a good reason. The template array does not have the data in it because we didn't call the function which gets the data. So, up here, within the switch controller, upon successful login, we will need the contents of the table to display. So, we need to check to see if we're logged in up here. Check to see if the login attempt was successful. If TPL at logged in. Well, actually, we also want to check to see if it exists. There we go. If so, we want to run get credentials table. Now that we're actually performing the work, we have a syntax error on line 45 of controller. Let's take a look. Line 45. Oh yeah, well. There we go. And there you have it. Ta-da! Our HTML table has been shown. Make sense? Any questions? All right. Well, let's see here. Okay. Well, if there aren't any questions about that, I guess I don't really have anything else for you today. So I guess we can get out of here a little bit early. Are there any questions? Can I see a motion to dismiss class? Anybody? You have to put your hand up. Okay. You are forwarding the motion. Do I hear any seconders? The motion is seconded. All in favor say aye. All opposed say nay. The motion is carried. Be it carried that class is now over. Thank you very much. And I'll see you tomorrow.
I listened to your last Tuesday. Can you get my text back?
Now recording. So, today, I thought we might start by going through the starter code provided in assignment 4. I can give you a detailed description of it. We can take a look at what's going on there, how to set it up, etc. This should be helpful in your pursuit of assignment 4. So, sound good? All right. So, let's remind ourselves. Sorry, question?
It says the document is locked.
The document is locked. Really?
Yeah.
Interesting.
And that it's like, what's it called, it's currently locked.
Currently locked.
It's currently locked.
It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. It's currently locked. Do you mean the assignment document?
No, the starter code, like the link to the zip file.
Did you click this one or this one?
I clicked both.
And it says it's locked both ways?
Yeah, I tried to download it, it says, file, it says file wasn't available on the site for me. Try saving?
It's very weird. All right.
Oh, it's missing the L.
I'm just posting it to the announcements feed. Let me know if that works.
Yeah, it was,
Awesome. Okay. So, so the first thing to talk about is, of course, the overall structure of the files themselves. So if you'll recall model view controller architecture, we have the controller. What is the controller? What is the controller responsible for again? What does it do? Recall is an important process of the process of studying, so that's why I asked you.
Respond to like requests.
Respond to requests, yes. So incoming response packets enter our server-side code architecture at the point of the controller. So you can see we have app.ctrl control.php. This is the top level file. We also have model and view, which are, model and view respectively. We also have app.config.php. The primary purpose of the configuration file is to set up the connection to the SQL database. So, let me show you how to take this code, integrate it into XAMPP so that your application is viewable. In order to do that, of course, we will need XAMPP running. There we go. And let's get Notepad++ while we're at it. So, within the htdocs folder of your XAMPP installation, you should create a new folder for assignment 4. Inside of this folder, essentially, you should take the starter code and decompress it. So take all of these files and drop them into the assignment 4 directory. So far, so good. So now, assuming XAMPP is running, we should be able to go to localhost 1080/A4, and we get all of our files in the usual fashion. With me so far? Good. The controller is the entry point, and we can see that our connection has failed This is not surprising, as we have not yet set up the database. Our next task is to set up the database. You will notice that provided here is tracker.sql. This is the result of exporting a tracker database. So what we want to do is we want to go to the admin page for the SQL server. There we go. You remember this guy, I hope. Import, choose file. You'll want to select the file in the file system. You'll want to select tracker.sql. Click Go, and import has been successfully finished. There we go. You'll see that a new database entitled Tracker now appears in our list of databases. We should now be able to reload the page, and suddenly we have our behavior tracker application. Ta-da! So with assignment 4, we're no longer really messing around in HTML and CSS. There's no longer a requirement that things look pretty with Bootstrap or anything like that. We are working now exclusively on the server side. So you'll notice that we have lots and lots and lots of little lots of things going on here. So in the first case, we have our behaviors record, our behaviors database table. This is a reasonably straightforward view of the data contained in the database. If we take a look at the tracker database and take a look at the behaviors table, you will see that we have identifier, student name, behavior, severity, time, a time stamp, lasted hour, no. You can see that ID, student name, behavior, severity, date, time. We are missing one field that is represented in the database. One of your tasks as part of the assignment is to create a new column in this table to represent that data which is not currently being represented. Does that make sense? Good. So, let's consider the create record form for a moment. You can see, aside from ID, which is automatically being generated, we have student name, behavior, and severity, and date time, which are all fields being collected from the user. Now, reading the description of the lasted more than 1 hour field, what you're supposed to do with that, this field should default to no when the record is initially created. This is why that entry does not appear in the form. It has a default value, as given. There should be, however, next to the value in each row, a link that when clicked will update the behavior record's value to yes. So you will need to insert not only the specific yes or no value stored in the database, you will also need to insert a link within that cell in the table that will update whether or not the behavior has lasted for more than 1 hour. So for reference there, I highly recommend taking a look at the encoding of the other links in the table. So let's take a look at some source code now. Let's take a look at the view. So these two lines are the table entries corresponding to delete, and update. Now, a piece of information that is necessary for the PHP script is what entry am I deleting? What entry am I updating? That information is given as the ID query parameter. It's being populated with the behavior, with the ID field from that entry in the table directly spliced into the query parameter. So when you click the delete link, you will see, here we go. You will see that the query that was attached was delete ID3. ID3 has been deleted from the table. Does that make sense? Good. Basically, you will reformat that link, but rather than deleting an entry, you will link it to a new SQL query that updates lasted more than 1 hour to true. Does that make sense? Good. Any questions so far? Okay. So. So, let's talk for a moment about severity sort. So, our existing code does not order our data according to anything. However, this is a useful thing to be able to do. The order by SQL phrase can be attached to a select query. Select star from table where condition order by ascending or descending, right? So you will introduce 2 additional links inside of the header, right? Inside of the header of the table. That's given here. This is the header of the table, right? Here, you will insert 2 links. One with a little up arrow, the other one with a little down arrow, ascending, descending. So, in the same way as here, you will send a query parameter that tells the PHP script whether we should be starting by ascending or descending severity. Does that make sense? Perhaps we should also take a look at the model. one way that you could approach this is to take the existing get all behaviors function, add a parameter to it that tells it whether it should sort by ascending, descending severity, or non-whole, right? And then the controller will feed the information into that function as it receives parameters or fails to receive parameters from the user. So let's take a look at the controller then. Controller, there we go. So you can see we have our action being read, our ID being read, student names, behavior, student name, all of the fields that might be used when you're creating or updating the form are being read here. The TPL is initializing all of its booleans next. After this, we have the switch controller itself. You will need to add a couple of actions to this. Sort ascending and descending. One way to implement those is to implement them as different actions that you will need to add to the controller. Delete all will certainly be a new action that you will be adding to the controller. The lasted more than 1 hour behavior will also require a new action because it requires an update of just the lasted an hour field. And then the duplicate will again require another action to be added to the controller. Does this make sense? Cool. So the way that you add a new action to the controller, right? You decide what the name of the action should be. You write a link that sends that action the same way as the other links. Like you've been given working examples of how to do this, right, in the code. Take those and adapt them. Then, inside the switch controller, add a new case for each thing that you change, or each new thing that you're adding. Does that make sense? Good. Duplicate is a little bit, it's a little trickier than it sounds. Basically, you have two options, right? Embed into the duplication link a query that reproduces all of the data in that entry of the table, so that you can add a fresh entry with all of that data. Or this becomes two SQL lookups, right? If I'm duplicating ID 37, I'm going to sneeze, just give me a moment. Pardon me. First, you select existing entry with ID 37. Then you create a new insert query using that data, right? Unless SQL has a duplicate operation, it might. We didn't cover it in class, but maybe it has one. Find duplicates, create duplicate. Yeah, this is too complicated. Do it the way I asked you to. Just read the data into PHP, then send it back again. Okay? Good. So, are there any questions about that? Okay. Any part of the code that you'd like me to go through? Anything opaque? Not really? Okay. Well, in that case, I think I'm going to get a jump start on next week's material. So, next week we're going to be talking about cookies. We're going to be talking about user authentication and validation. So, one of the things that we're going to talk about is what constitutes a good password, right? Passwords are kind of, you really, like, you can't get away from passwords. Password systems are the best way of securing accounts and data on the internet, even though, people have tried to unseat them, right? Using various, oh, here's my new scheme for validating people. None of it has been as good as just a plain old password. But not all passwords are created equal, right? There are good passwords and there are bad passwords. So, if it is permissible, I would like to show you guys a video on the subject of password cracking. I hope you'll find it interesting. But it goes through a few different principles behind what makes a good password and what doesn't, from the context of how easy does it make it to crack them. Does that make sense? Okay, so I'm not going to replay someone else's YouTube video on this YouTube video, but I'll show you a static picture of what the YouTube video is so that you can watch it on your own time, perhaps immediately following this one. YouTube.com. Computer file password cracking. There we go. Is this the one I want? All right. This will be, a picture of a nerd talking about passwords, which is an alternative to another nerd talking about passwords. Okay, I'm going to stop the video now.